Okay, now members, let us see how we can handle this question. It says, a uniform ladder of weight W rests at 60 degrees to the horizontal with its foot on a horizontal floor and the upper end against a smooth flat wall, so the wall is smooth. If the ladder is at a point of slipping, it means that it's limiting equilibrium. At the point of slipping, when a man twice the weight of the ladder stands at upper end, find the coefficient of friction between the ladder and the floor. So, okay, so now this is my wall, vertical, this is my floor, horizontal. Of course, because this is my ladder, means that there is contact here, so meaning we expect a reaction at A. If I call this the point A, and I call this point B. Even here there is contact between the ladder and then the floor. So there is a reaction at B. But our flow is rough. So you expect friction. So friction is going to be coefficient of friction, then times the reaction at B. Okay, so we are almost there. This is our A. Now they are telling us that, of course, this is the uniform ladder and they are giving us the weight. So meaning if it's a uniform ladder, it means that the weight is going to be in the middle. So now it's that they are not giving us anything like the length of the ladder. So we say let 2L be the length of the ladder. Okay, so these are now my weight is going to occur in the middle, so this is my midpoint. W. If they give us weight, don't multiply by D unless they give us mass. So, because we are saying this is 2L, this is going to be L, and this is going to be L. Because this one is occurring in the middle, because the ladder is uniform. Okay, telling us it's making an angle 60 degrees with the horizontal. That's what we have so far. Okay, what is now? B. If the ladder is at a point of slipping, when a man twice the weight of the ladder stands at the upper end. So now we have a man standing at the upper end twice the weight of the ladder. So meaning it's going to be exerting a weight which is 2W twice the weight of the ladder. That's where that man is going to be. So then I ask find the force, find the coefficient of friction between the ladder and the floor. So they want this mu. First of all, we resolve. Let us resolve vertically. Resolve vertically. We have RB, I think it's the only vertical force, equaling to 2W plus W. So from here, my RB is going to be 3W, and I call this equation 1. So resolving horizontally, is that I'm going to be adding mu RB, I'm going to be adding that, going in that direction first. RA is the only force I think going in that direction. So it's going to be equal to this force, which is mu RB. So I have my RB. So my RA is going to be mu into RB, 3W. So RF from here is going to be 3 mu W. I call this equation 2. Okay, now you said if you want to get one of the directions, you take moments at either A and B. But it's easier to take moments at A, I mean B, because you have many forces from B. So it's better you take moments here, and so that you can easily determine the perpendicular distance of this and also of that force. So taking moments at B, where you see, you want to get this, so let us take them clockwise. But you can also take them anti-clockwise. So, if you see clockwise, we are going to be adding now from B. I think you can see this is where this force is acting. I think it's the direction. I think this is going to act clockwise. So, we are having RA, then times the perpendicular distance. Now, because this is a horizontal force, the perpendicular distance is vertical. So now we need this. So there we draw our simple diagram here. This is 60 degrees. This is A. This is B. So you see, this one is going to be 2L. So if I want this, you see this is opposite, so it's going to be 2L sine 60 degrees. And this one is going to be 2L. This is adjacent, cos 60 degrees. So, means the perpendicular distance from here to this point, meaning the perpendicular distance from here to here is the same as from B to that point there. So, I'm going to multiply by now 2L sine 60 degrees, I think. Now, that's the only clockwise force, I think. It's going to be now equaling to this one is acting anti-clockwise. We have this one and we also have this one. So, we start with this one. So, 2W times what's its perpendicular distance? Because it's vertical, this perpendicular distance has to be horizontal. So, from here up to here, what's the length is there? 2L cos 60. Then plus, we also have W times what's the perpendicular distance. Now this one will draw because its hypotenuse is L. So now I didn't draw it here. This is 60 degrees. This is L. So meaning if I want from here up to here, I have this. This is adjacent. So L cos 60 degrees. Cos 60 degrees. Like that. So now we can simplify. You know what sine is? Sine 60 is. So this is going to be RA times 2L times root 3 over 2 equaling to 2W times 2L times cos 60 is a half plus W times L then times cos 60 is a half. So now it's that a half is common, so you can multiply through by 2 by 2 by 2. Then what is common again? We have also L common, and L common. So what is going to survive? You see from here you shall be having 2 root 3 RA. The only thing surviving 2 root 3 RA equaling to here we have 2W plus here we're going to have W. Is it? We have W surviving here. W there. So I think that's the only thing we have. So what's going to happen there? We are going to, which is going to be, you see this C. Sorry. This is 4. This 2 times this is 4W. This is 4W, which is going to give us 5W. So it means that now my RA is going to be 5W divided by 2 root 3. So you can rationalize that if we want. It would be, how do you rationalize 1 by root 3 here and root 3 here? Okay. Let me not skip that step. Okay. 5W over 2 root 3 times root 3 times root 3 up and down, separating nothing. This would be 5 root 3 W, the whole over root 3 times root 3. That's going to be 3. This time this is going to be root 3 times root 3, that's root 3. Times 2, that's going to be 6. And I call this equation 3. Now, because this is RA, and we have RA there, it means that now our 2 is equaling to 3. So what is 2? 2 mu, 3 mu, W is going to be equaling to 5 root 3 over 6 W. So that W is going to cancel. So from here, you can set our mu. It's going to be 5 root 3 over, divide this to the side, give you 18. And that's going to be our mu, which we are looking for. So this is our part A. Then part B, friction force between the ladder and the ground if the man stands in the middle. So now for part B, I'm going to re-sketch this. So let me first pause the video. Okay, so now this is what we have, the new diagram. So now because we are changing, this man is now standing in the middle. reaction here is going to change. It's not going to be the same reaction as there. So that's for this one, reaction 1, and this one, R2. So now, here, because this man is standing in the middle, it means that now here, the weight is going to be the W for the ladder, then plus the 2W for the man. That's now going to be our weight. Okay, so here I'm going to be having friction, which is going to be mu, then R1, as simple as, R2. So that's what has changed. Still, resolve horizontally and vertically. So, resolving vertically, you see, resolve vertically, so our R1, our R2 is going to be equal to 3W. So this is our R2 equation 1. Then resolving horizontally is that our R1 is going to be equal to mu R2. So my R1 is going to be 3W mu, because this R2 is there. So I call this equation 2. Still, I'm going to take moments at B. Taking moments now, let me take them anti-clockwise. So, to take moments at B, any force coming out of B, its moment is going to be 0. So, anti-clockwise, now I'm going to be having 3W, then times this one, going anti-clockwise, times the perimeter distance from here up to here, which is from here up to here is L cos 60 degrees, equaling to this force going that side, which is R1, then times its perimeter distance from here up to here. Remember, the ladder is not changing its length, so it's going to be 2L sine 60 degrees, which you can say this is going to be 3W times L times cos 60 is half, equaling to R1 times 2 times L times half, root 3 over 2. Cos 60 is root 3. Sine 60 is root 3 over 2. So start this one, can go. Then this half, can cancel with that. And then instead we shall be having here, what's going to survive is our 3W. 3W is going to be equal to 3 R1. So implying that now my R1 is 3W over 2 root 3. Okay, so from there, you see, I'm going to equate that. Now I call this one equation 3. Okay, so I call this equation 3 in this new diagram. So it's that now my R1 is going to be equal to R1. So meaning my 3W mu is going to be equal to 3W over 2 root 3. So these two we are going to cancel, which will be 1 over 2 root 3. So from there, what is going to happen is just to rationalize. So multiply root 3 up and down. So our mu there is going to be root 3 over 2 times this, 3 times 3, that is 3 times 2, root 3 times root 3, we get 3 times 2, that's 6. So if we have that, then we can come here and we get our F. Remember, we are interested in F. So our F is mu R2, which is going to be mu. My R2, so my R2 is 3W, and my mu is known as root 3 over 6 now times R2, which is 3W. This one by this 2, so my F is going to be W root 3 over 2, and it's going to be in newtons. That's how I'm getting my friction force. So that's how we handle those two. When they tell you the man change the position, you immediately also change. So that's it, members. I wish you well.